Remind me after I get this straight. Okay. So this is implicit differentiation. Doesn't really matter that you know what it's called. Matters that you can recognize like when to do it. But right away, like what do you notice that's different about that equation, that equation, that equation than we've done so far? They're what? There were y's before. So we have two variables in there, right? We have the x and the y. All the ones we've ever done has been like y equals, like y was equal to something, you just take the derivative and everything's fine. This is a little different. So you do this when you have like y's and x's mixed in together. What the theory is, don't necessarily understand the theory to do it, but I want to try to explain it. Like this is not solved for y. I can't solve this for y. Because that's a cubed and that's a regular, and I just, like, if I cube root it to get that to be y, well, now that's like a cube root of y, and then I just can't get into. We good back there? There's a lot of motion and getting stuff out. And Gavin wasn't really the problem. So there's this assumption that it is possible to solve for y. We just don't have the tools to do it. So y represents like a function. So when we take the derivative of it, we have to take the derivative of the inside of it also. It's chain rule, basically. I have no idea what y is, but I know that it's theoretically possible to solve for y. So this equation I could kind of think of like this. I can solve for, like, it is theoretically possible to solve for y. I can't, but it's possible. Whatever y would be equal to in this theoretical world where these tools exist is kind of in there. So if I took the derivative of this, wouldn't it be 3 times blah, blah, blah squared times the derivative of the inside? It would be like blah prime. That's my fancy calc notation. So that's the idea. Let me just start doing it. See how it goes. So what you do is you take the derivative of everything, x's and y's, but if you take the derivative of a y, multiply it by dy dx. That represents the derivative of that imaginary thing that we don't know what it is. So we're going to take every derivative. If there's a y, when I take the derivative, I multiply by dy dx. So like the derivative of y to the third is 3y squared. And I took the derivative of a y. So I multiply by dy dx. Again, I don't know what y is. Theoretically, y can be solved for, and it's in there. So when I take the derivative of the y, it's really just chain rule that's making this dy dx up here. You don't need to fully understand that through the problems, but try it. Derivative of negative 2x is just negative 2. That's an x, so we don't multiply by dy dx. Derivative of x to the fourth is 4x to the third. Does not have a y, so we don't multiply by dy dx. And then the derivative of 2y is 2. I took the derivative of the y, so I multiply by dy dx. And so if I solve for dy dx, dy dx represents derivative. So if I solve for the derivative, even though I never knew what the original function was, if I solve for y, it's like not possible based on our tools, I can still find the derivative of that. So I'm just going to, now it's just algebra. This is your variable, and you want that by itself. So collect all the things that have dy dx's on them on one side, move all the things that don't to the other side. So this will be like 3y squared times dy dx. This will be negative when I move it over. And the negative 2 will be positive when I move it over. want dy dx by itself. How can I get it out of these two things? What's that called? Undistributed factoring. So dy dx, if I pull that out, I get on the inside 3y squared minus 2. And then we want dy dx by itself. Right now it's being multiplied by this thing, 3y squared minus 2. So I'm going to divide by that thing, 3y squared minus 2. Those go away, and then this is your answer. So I could ask you, like, what's the slope? I might have to give you an x value. Well, you would need an x value and a y value. Sometimes I'll give it to you. Sometimes I'll give you either the x or the y and make you use this to find the other one. And this represents the slope, the derivative, just like any other derivative. It's just got x and y's both in it. Also, I want you to understand that, because you'll go check your answers sometimes, and the book like decided to gather, or the answer key maker, whoever, decided to gather their dy dx on the other side of the equation than you. It doesn't mean you're wrong. If you have every single sign in there the opposite, then you're good. If all four signs, like if all the signs are opposite, positive, positive, negative, negative, positive, negative, negative, positive, you're good. Those two things are equal. Question on that? Yeah. Here? It's supposed to be a fraction, yeah, but the blue on black didn't go so well. So, like, do you see where it's coming from? Yeah. So I'm divided by that, right? Alright, before I do 2, because that, to me, that's a pretty big level jump. Yeah, you guys try. I just have to play for a second. This red line, intro regular geometry, I described how to write down the equation of this line for a half an hour. 10 different ways. I like half my class still can't do it. I don't know. Like how else? How would you guys describe it? Yeah, tell me how to do slow. These are pretty much the things I said. Okay. Anyway, try this one. Let's say 3x squared minus y squared equals cosine of y minus e to the x. No, e to the 2x. Throw a little chain rule in there. Careful. So that should be your first step. so questions on the first step here? So remember, you're taking the if you take the derivative of a y, only a y, you multiply by dy dx. And then it's just an algebra problem where the only thing that matters is to get that dy dx by itself. So I'm going to bring this term over, which makes, that'll be positive over here. I'm going to bring that over, which makes it negative over there. Then you factor out a dy dx. You'll end up with sine y. And you guys will probably pretty quickly start to skip this step. And that's fine. Like, where's this stuff going to end up? It's going to end up on the bottom of the answer, right? So some of you, I think, will start jumping from, like, this step to the answer. Because it's just going to be that over, like, whatever's left after you remove the dy dx. You don't have to. I'm just saying, like, that's okay. Because it is just going to end up on the bottom over here because you're going to divide by it. And again, if you have every single side opposite, it just means you gathered on the opposite side of me. Totally fine, there's no right or wrong. So you would have that. Question on this one? We're good? Alright, go back to your, I'm going to do it this. I got more room here. Number 2 in the notes. Bless you. So now, that is going to be implicit differentiation. How do I know it's implicit differentiation? Two variables and like the y's and by itself, right? And I can't really get it by itself. When I go to take the derivative, it's a chain rule. So you take the derivative of the sine, you'll leave this alone. Then you'll multiply by the derivative of this. Well, what do you need for the derivative of this? They're being multiplied. Being producted. Product rule. Yeah. Product. I don't know how to say it. So, the big guy is my sine. The little guy is my xy. I take the derivative of the big. The derivative of the sine is cos. What do I do with the little guy? He just stays until I get to like his level. So I did the big. I left the little guy alone, and now I multiply by the derivative of the inside. I'm going to write this, just like watch me do it, and then, because there's a really common mistake here. So people will do fig plus gif. So what's fit? F prime. What's fit? Not fit. F, like, I want F prime. Fig means like F prime times G, right? So it's 1. Well, a lot of people were saying that. Tons of people were saying that. So, first thing, derivative of the first thing times the second thing. Have I taken the derivative of a y yet? No. I took the derivative of an x and I just rewrote the y. Plus, and there's my mistake, the derivative of the second thing. So what's the derivative of y? It's 1, but then we took the derivative of y, so we're going to multiply dx. So that's my g prime, and then I multiply by x. So I can put parentheses there. But and a lot of people do that, and then they'll go, okay, the derivative of 10x is 10. And they'll keep going. What mistake did I make there? What'd you say? I think when I tell you, you'll be like, oh yeah, that's I don't know. Yeah. No. It's like it's not even a calculus thing. It's an algebra thing. Yeah, you see parentheses. But people do this all the time. So like, if I do it like this, I am multiplying by f prime g, and then like totally separately adding g prime f. But you want to multiply it by the entire product rule, so you need parentheses there, or brackets, or braces, whatever you want to do. What's up? Does that make sense? Okay. So now my job is to. Well, are there questions on the first step? I gotta get dy dx by itself. There's a little trick here. One way you could do it would be like distribute, move things around. Like that will work. But a little easier way. What if I divided by cosine of xy? So on the left-hand side now, I'll have y plus x times dy dx. And there's absolutely nothing wrong with writing 10 over cosine of xy on the right-hand side. Usually on the AP test, they won't write it that way. So just to show you what they would probably do, I don't want that on the bottom. If I want to move cosine to the top, what does it turn into? No, because it's a trig function. There's a name for it. It's secant. The reciprocal of cos is secant. So you can rewrite this as 10 sec xy. And it's not wrong to write this. But the AP test will probably write it like this. I'm just trying to get you used to it. And then it's just like get dy dx by itself. So I would subtract y. And then I would just divide by x. And that's your answer, or all the sides reversed. Question on 2. Okay, so your homework is 1 through 13. This is a 2-day lesson, but I'm splitting it up into like 2 lessons. Not 2 work days. Yeah. That's not in the way.
Just in case you're standing on that side.
Just in case I'm all of a sudden left-handed. You never know.
Yeah, it's really.
I have never had a problem.
It's more, I think, like.
Wait, I have a question on the problem.
Yes.
Yeah.
So instead of writing 10 divided by cosine,
Oh, yeah. Oh, you just moved it up.
so the reciprocal of cosine is c, right?
Yeah.
So I moved it up. And you don't have to. I was just like, in a multiple choice situation, that's probably how it would be written. So I'm just trying to show.
But we would still get it right for you. We still get like left on the bottom, right? You said
1 through 13 in section 3.2. And then tomorrow, I think you probably know what's coming. With implicit differentiation, find the slope, find the equation of tangent line, find the horizontal tangent line. Same stuff we've been doing, just with a new way of taking the derivative. Right now, you should be working on 1 through 13 yet. And let me know if you have questions.